This is the Royal Institution in central London. It was here, in the famous Faraday Theatre, that Sir Christopher Zeeman became the first mathematician to deliver a Royal Institution annual Christmas lecture. That was in 1979, and Professor Zeeman's televised lectures were called Mathematics into Pictures.
Well, welcome to this year's Christmas lectures. Mathematics is not quite a science, it's halfway between an art and a science. On the one hand, it's the art of proving theorems, and on the other hand, it's the universal language of science.
These lectures influenced many young mathematicians at the time, as the professor looked at mathematical topics, such as the topology of knots and loops.
There you are. And now you've got to get free. Good. So you have to press the function key first, and then log. That's right.
He also looked at the properties of numbers
divide by two triangles
and their links with geometrical shapes.
Ready? Go.
He demonstrated the maths of music
Now, what's going to happen?
and the properties of waves.
Now, they're going together, and then they go through one another and come back.
He even included some mathematical proofs,
And therefore, A must be odd.
as well as a few big bangs.
To that mirror.
It was from these lectures that the Royal Institution's maths masterclasses for schools developed, which now take place in different centres across the UK. During his long and distinguished mathematical career, Professor Zeeman specialised in the study of geometric topology and catastrophe theory. Now aged 84, Sir Christopher still has an interest in mathematics education. In the office of the Director of the Royal Institution, a group of teachers have come to meet him and talk about maths.
It'll be nice to hear, what do you think is the purpose of mathematics, the nature of mathematics?
The nature is to understand things better.
We'd like to get a sense from you as to what mathematics teachers should be engaging with to develop their own mathematical thinking.
Yes, well, my main feeling about mathematics is that students should be taught theorems and proofs. Theorems and proofs are the core object of mathematics.
Actually, I really agree with you. Obviously, I'm coming from a French background where theorems or proof are at the core of our maths education. And I do think that even for younger people, even from younger people from inner city London, the fact that theorem and proof is giving them a structure, and maths is all about, getting your thought organized, rationalizing, and always applying maths. You're removing a big part of maths, which is doing it for itself.
While I think this is a fascinating area of mathematics, I'm not sure all my students, some as young as 12-year-olds, are actually ready to engage in full theorems and proofs. They need to have some background to reasoning before they can actually engage successfully, I think, with theorems and proofs, and that needs doing, and it seems like we're almost stuck in that stage throughout high school and occasionally do touch theorems and proofs, but I agree with you, not enough.
The problem in the fact that most of us as teachers are in this exam culture where we feel, I'd love to do more enjoyable maths, but I still feel that my pressure is to make results.
I think it's an interesting dilemma that teachers are in about doing what they might think is more interesting maths than for fun, but my experience is that actually if you do that and push students to think more for themselves and get more interested in maths, then they do well in exams, and I don't think the two things are mutually exclusive, actually.
Do you think a lot of teachers aren't knowledgeable enough to move to this abstract world?
That could be part of the reason, but I don't think it's the whole reason. I mean, the curriculum is divided in very clear 4 categories. Where does theorems and proofs go in there?
I'm sensing some consensus that people are okay with the idea of doing more theorems and proofs, but it's not quite clear how it's to be done and whether we have that sort of depth of knowledge and confidence.
It's true, in selecting the theorems and proofs, I'd choose ones which are very, very appealing, easy to state and understand, and easy to explain completely.
Do you have an example, or?
Lots of examples.
Okay, let's have a few.
There are an infinite number of primes.
Okay.
You assume that there are not a finite number, and then you list them all and add one.
It doesn't matter how many primes we have. That's not the issue. The issue is a reasoning, is a way of thinking. And I think a lot of proof is not about showing, the circle theorem. It's about how you organize your mind and your thoughts to make a thing that you can't refute.
Yes, I've recently done quite a lot of work with students trying to discover some of the circle theorems for themselves, but actually give a rigorous proof of them. Their proofs were not formal taught proofs, although they were rigorous. They were drawing angles in triangles and definitely dealing with generalities and not with just examples. Do you think that's sufficient for them to come to it that way?
No. They must have eventually complete proofs, rigorous proofs, independent.
So would you be happy for them to start in that way, exploring with dynamic geometry or whatever?
Yes,
and
fine,
then
that's fine.
it should be taken on to a rigorous formal proof at the end?
Yes, I think so.
A proof shows that in any case, and that's a concept that's, in itself is beautiful.
And I think that's a concept that teachers have to work with all the time in their classrooms. So every opportunity, we're pointing out the difference between example and proof.
And this layer of proof and theorems needs to be there constantly and built over years. And usually we touch it far too late. And coming back to Matt's point on GCSE exam, 2 questions, 6 points on proof. Here's how you do proof, is probably what's happening quite a lot.
Geometrical proof can be handled in year 7 and be quite formal about it. And then, then you can build it into algebra easily, because they've got the idea of how you build a proof. But because we do very little geometry, we're missing that opportunity. I agree that you need to make it, appealing for everyone, but then sometimes those things different will make it appealing. Sometimes making them get out of their world, which is not always a nice place, will make it appealing for them, because it's beautiful to be lost in algebra. Okay, maybe not for everyone, but and you don't have to worry about the words. You're in your own little world of itself. You manage to do things. You learn new things.
Just a sense of achievement of actually understanding a piece of math.
And also doing something abstract, something that is not related to a word you might not really enjoy or like.
I 100% agree with you. I think it's fantastic what you're saying. But I think we have a lot of teachers who haven't got the confidence or the skills to do that yet and to get students to that point.
How many times have you heard the question, why am I doing this? What's the point? When am I going to use it? And I'm very interested in the conversation we're having. It's brilliant for 1 or 2% of...
No, I embrace that conversation. I love it when they say, why do I use that for? It happened to me last week when on third.
If I'm honest, sometimes I worry and I think, I can scratch my head and I will give them an answer. But they're asking when will they use it, or not when can one use it. And that's a subtle difference.
So how do we get a whole generation of teachers and students to get comfortable with that? Do you have some solutions about how we can get teachers engaging with this sort of approach?
Well, you have to find a subject which is playable. So you have to, and then you exploit the play area, and generally there's some sort of surprise to it.
Some students do have the talent to grasp all these rules, to generalize properly, perhaps to root out their own misconceptions very early, and they're ready to play with theorems and proofs and other things, and some may not. And us as teachers in the classroom, we have to cater as well for those who cannot.
Yes.
We're also trying to break down the barrier of years of the dentist theory of you go to a maths lesson, maths is done on you or to you, you leave, like going to the dentist. People don't want to go to the dentist because they don't like it. And that's the sort of the theory. That's the problem. I think it's just so ingrained now with lots of students at school level that their parents say they don't like maths. I've been to hundreds of parents' evenings where the parent says, "I never like maths. You don't like maths, do you?" And they say it to their child. They say, "No, I don't like maths." And you think, "Oh, they're such a good mathematician," or they could be. They just got this trigger in their head that says.
There's definitely a social.
There is a social, and there's also a high-stakes game, so you can't introduce the play too much, because there's so much. It is, it's there on every testing regime. Numeracy, literacy. What are they coming out with? So
well, I think you've got to have the confidence to do that, because I firmly believe that if you do give children opportunities to play with mathematics, you won't damage their assessment at the end of it. But I think you have to be a very confident teacher to believe that.
At the same time,
And
exactly what you said about, I love the dentist, I've never heard it before. But no, what one thing they've noticed, and I've noticed it, because when you do maths and you play, I play with them. So, and I say, who wants to mark mine? Who wants to look at my answers? Because a lot of time what the kids said is, are you doing maths as well? Because I see sometimes the teacher as the one telling them, or being the dentist doing things to them, but they don't see us play. And if they see us enjoy it, when I was doing the search, I was like, oh, who's going to beat me? And suddenly they were like, you're doing it. And I was like, yes, obviously, because, and suddenly it built a confidence. And I think that one of the things is that they don't see sometimes math teacher enjoying the math and doing the math. And that's part of the enjoyment. If you play with them, if you a part, not a facilitator, a part of the game, then that's part of where you see, I'm having fun. You're having fun, I'm having fun, and they can see it as an adult thing as well.
Following on your idea that you're doing maths as well, bring an idea to the class and take it wherever it goes without you putting a 5 minutes lesson plan into it. So just bringing a question into class and exploring it together with the children, giving them the notation that you're exploring with them. And I've done that in some of my classes. Sometimes I go in with a problem that I don't have the solution for. And all I have to have is the competence that I will be able to take it forwards with my students as far as they can go. Leading them, exploring something together through a discussion, which leads them to generalization of mathematics, which will get them ready for theorems and proofs.
I feel for an English teacher or history teacher, and this may be my ignorance speaking, it's easier for them to engage with the doing and the challenge and the play. During the summer they can go to a play and take in a new novel. For mathematicians, we make it a lot harder. I mean, you seem to be quite engaged with playing with your children in classrooms, but some of the teachers find it very difficult.
Yes.
And I know that in the master classes you have engaged with students and with teachers, and everybody sort of playing on the task together.
Yes.
But when you started in mathematics, was it the play that got you in? Or?
I emphasise on the play. Yes. If you stick always to the theory, then no damn good.